All right, welcome to the final installment of the EOC practice problems. This is the EOC set 61 through 80, but I'm doing the second part of that set, 71 through 80. So it's our last 10 problems. We're not going to skip any of these. These are logs and exponential functions, stuff like that. So we got to remember all that stuff. It's hard. It's hard to bring all these rules into our head. That's why we practice. And believe me, as hard as this maybe has been this week, to pull all these rules back into our head and to revisit all this stuff that we desperately wanted to forget, it's going to serve you really well here in a couple of months. And we're going to have to do it again because all of these rules will become gray again over the next few weeks. Want them to be in bold before you take that test, all right? You'll feel more confident. All right, so what is the value of log? Okay, so it's obviously just calculator work, but if you happen to not have your calculator for this problem, remember that since there is no base, the base is assumed to be 10. And remember that a square root sign is the same thing as a 1/2 power. So if you remember one of your properties, if the base and the big number are the same, the answer is the exponent. It's just right there because 10 to the... What does 10 need to be raised to be equal to 10 to the 1/2? Well, duh, it's 1/2, all right? Let's keep moving. I don't mean to say duh, I don't mean to sound condescending at all. This is not that easy, but it's all doable. It's all doable, all right? So we gotta solve for x in this thing. This is log base 2x of 80, and that equals 2. Almost anytime you just have logarithm equals something, you're going to switch that into exponential form. Remember, the answer is the exponent. This is your new base. The base stays the base. So it's like this, but it's the whole 2x squared. Not just the x, not just the 2. It's the whole 2x squared, and that equals 80. So now we can just go 4x squared because I'm going to distribute. You distribute power. 4x squared equals 80. Divide both sides by 4, x squared equals 20. Take the square root of both sides. Square root of 20 breaks into 4 times 5. I pull the square root of 4 out, and my answer is 2 root 5, or B. All right, rock and roll, here we go. That's what every dad says as he's leaving a restaurant. Okay, guys, let's rock and roll, right? Okay. So I had a little trouble with this one earlier. How did I solve it? I solve all these ahead of time to make sure that I don't spend 30 minutes doing 10 problems. So what is the value of x? Oh, x is already solved for. We just got to figure out what that is. Obviously, if you have a calculator, you type it in just like that. Bam, you're going to pop out. It's going to show you your answer. But what if you didn't have a calculator? Okay, first of all, we're going to forget all about the 4 for now. We got to try to write 127 as 3 to the something. And I'm just going to go ahead and tell you because it's pretty tough to figure out. It's 3 to the negative third. Because the negative 3 to the negative third, you would do this. You would flip it over to make the exponent positive, and then 3 to the third is 127. So I just worked backwards. I turned 127 into 3 to the negative third. The log base 3 of 3 cancels. I'm left with a negative 3 times 4, or negative 12. All right? There is another quick way to think about it. Log base 3. I did this earlier, and it worked, but I made a careless mistake. So it's log base 3 of 1 over 27. It's log base 3 of 1, log base 3 of 27. So if you remember this property, if you have division in the main number here, or the value, then you can you can split it up into subtraction. So I'm going to split up the 1. This is our old numerator, okay? This is our old numerator, and this is our old denominator. So I just split it up. Division splits up into subtraction. And then here's the tricky part that you have to remember. We talked about this earlier. Log base 3 of 1. What does 3 need to be raised to be equal to 1? What does any number need to be raised to be equal to 1? 0. 0 minus, and then what does 3 need to be raised to be equal to 27? 3, that's still times 4. 4 times negative 3 is also negative 12. Another way to think about the same problem, but obviously that would just be calculator work if you have your calculator. This one also, calculator work if you have your calculator. If it happened to be on the part where you didn't have your calculator, then let's talk about those properties that you have to use. And you got to keep them all in your head all the same time in order for this to go fairly quickly and fairly smoothly. And you can do that. You can do that. You just have to work a lot of problems in the days leading up to that EOC. You got to bring those rules back into your head, okay? So all we're doing, forget about the whole word problem. We're just solving this. We're plugging that in right here. So let's work this problem. 4 times the log of 10 to the negative 3 over 10 to the negative 5. Okay? 10 to the negative 3 over 10 to the negative 5. I don't know if you remember the exponent rule. If you're dividing something, if you're dividing the same base with 2 different exponents, you subtract your exponents. So, what is negative 3 minus negative 5? Be careful with that. It's minus negative 5, not just minus 5. That's a negative 5. So it's negative 3 minus negative 5 gives us positive 2. Well, my implied base here is 10, so once again, the base and the value there cancel. The answer here is 2. 4 times 2 gives us 8 decimals. Is it nearly as hard as it looks? But of course, the calculator would have been handy. All right, 6 more in the whole set. This formula gives our annual interest rate, R. There's our R right there. Required for your money to double in X years. There's the X right there, all right? If it takes 18 years for your money to double, what's the approximate rate? So all we have to do is plug in 18 for X. And this is going to be calculator work. I'm trying to think of if there is a way to solve it without it being calculator work. I can't think of a quick way. So we would assume that this would be on the calculator. Remember, a lot of the word problem, you do have to read it carefully. You have to read it carefully, but then after you read like 500 of them, you realize a lot of the word problem is fairly ignorable. You can just sort of look at what's happening and just plug in what you need to plug in. Now, you still want to read it, all right? But usually you can read it. Don't let the reading of it confuse you, all right? Read it carefully and then sometimes just go with your gut, all right? So we're just going to plug that in. 2 to the 1 over 18 minus 1 ends up being right at 4%, okay? Of course, it's a decimal. It's like 0.03 something, but you've got to reduce you got to round it. Turn it into a decimal first and then round it. Okay, this is 2,250 times e to the RT, all right? E to the RT. So, oh yeah, I had a little bit of problem with this one too. This was a tough one. I did it just a minute ago. I was able to finish it in under 2 minutes, but this one requires a little bit of work. So this is our Pert formula. The population increases, where T is the years, R is the rate. What equation solves for R? All right, what equation solves for R? So we got to solve for R, meaning we don't know what T is. We know what E is. E is a number, but we can't do anything with it yet. So let's go ahead and get rid of that 2250. It's 2250 times this value. That value we don't know. We just need to get rid of this. So I'm going to divide both sides by it, okay? Now I'm going to switch sides on you. E to the RT equals P over 2250. Okay? When you're dealing with E, especially if you want to get a variable down, you're almost always going to take the ln of both sides. That's the natural log. ln of E is the same base. The implied base of ln is always E. That's the definition of ln. The base is E. So these go away. You're left with RT equals ln of P over 2250. Divide, what are we solving for? R. Divide both sides by T. And it's a big, nasty answer, but there it is. ln of P over 2250 divided by T. And I know it seems easy when somebody else solves it, like you see it. But don't let that discourage you. Once you make that connection, about a certain type of problem 4 or 5 times, then you'll start to see it ahead of time. Okay, but you need to have that little moment of confusion, and then work through it and get to the problem. All right. So 4 more. This is 10 to the negative kt. Hey, if you guys are tired, believe me, I'm tired. It's more exhausting. I'd rather be talking to a full classroom. It's more exhausting to be in this empty room by myself, pretending like I'm talking to you. But I hope it's at least somewhat entertaining for you. All right. So the mass of the radioactive sample is given by m of t equals m sub 0 times 10 to the negative kt. All of that just sounds like a big mouthful, but don't let it intimidate you. All it's doing is this, okay? And I know that's not a little bit, that's a lot, it's significant. T is the time in years, m sub 0 is the initial mass, and k is a constant. We're going to solve for k because it asks us that. It tells us the value of this. It tells us the value at the end of the time period, which is over on the left, all right? So 400, I'm just going to go ahead and erase that and replace it with 400 in the interest of space, all right? So this is also like our Pert formula. Our final value equals the initial value times 10 to the negative kt. And we know what k is. We know what t is too. It's 10. So I'm going to call that negative 10k. Okay? All I did was replace t with 10. So now what? Now we divide both sides by 400. Because this is just multiplied, and this is a single value. There's just 2 things multiplied together, so I'm just going to divide by 400 to get rid of it. Boom, boom, gone, gone. You really learn after a while that these problems are written very much the same. That's why this practice was going to make you incredible at the actual EOC. So this, in your calculator, you realize that's 0.1 equals 10 to the negative 10k. Anytime we want to get exponents down, we're going to take the log of both sides. I'm going to pull those exponents down. I don't actually have room to do it, so please forgive me. I'm just going to pretend like they're down already. I'm going to pretend like I pulled them to the front, multiplied by log 10, but I'm just going to say it's log 10 times that, okay? Because it doesn't matter what order we multiply. Now, I divide both sides by, log 10 just goes away because the base is 10. What does 10 need to be raised to be equal to 10? 1. So that's what we've got. Divide both sides by negative 10. And we've got our k. Log, hang on, log of 0.1 divided by negative 10. Come on. Log of 0.1 divided by negative 10 gives me positive 0.1. Let's see if that answer is C, because that was not overly easy. Yep, C. All right, which equation has -1 and 3 as solutions? We didn't talk about this. We had a problem like this already on one of the sets, but we didn't really talk about this a lot, okay? If -1 and 3 are the solutions, if those are the zeros, -1 and 3, if those are the zeros, we don't really know what the thing looks like. Maybe it looks like this, or it looks like this, or maybe it's even upside down. It doesn't really matter. If it has those as solutions, then we can say that it has these as factors. We never really talked about that much. We talked about if that's a factor, then that's a 0. But we didn't talk much about taking the zeros or the solutions. Remember, zeros and the solutions are the same thing. Also, roots are the same thing. And you can just FOIL these. -3 is minus 2x minus 3. I did the outers and inners and added them in my head. So minus and minus is what I'm looking for. Nope, A. Okay? There's another way to do it. Plug each one of these in your calculator and see which one passes through that and that as zeros. okay? Not positive 1 and negative 3, as is, because the roots are where it passes through the x-axis. Or plug them all in and do the root finder. The root finder should be on your calculator. I would recommend maybe taking your own calculator or borrowing one of ours and we'll make sure the root finder's on it ahead of time so that we don't have that ACT issue like we did before. So this should be A. There it is. All right, 2 more, guys, 2 more. 2 more and you're done for the week. Hopefully you've taken your time with these, you've worked them ahead of time, and then you've watched my solutions. I hope that's the way you're doing it. Don't just go through, because I have to see your work. So I have to see you turn something in with the part at the top, EOC Practice 1 through 20 or 21 through 40 or whatever. That's what you're getting credit for, the paper, not the submission in Google Forms, although of course I'll be looking at that, see how you did. Which of these is a root? All right, use your root finder and find out which one that is. Or, we did go over this. This was one of those screens that we did when we were doing polynomial functions. We can also just divide each one of these into our coefficients. And what are we looking for here? What are we looking for here, Katie? Yes, exactly. If that is a solution or a root or a 0, we're going to get a 0 as the remainder, all right? So 1, -3, add -6, 18, add 16, that's 48 or something like that. No, that is definitely not it. So I'm going to do the next one, 3. Let's divide it into 3. 1, -3, -4, and 12. 1, 3, 0, 0, -4, -12. Bam! I believe my answer is B, because I got a 0 remainder when I divided it. Or remember, or you can just plug that into your root finder and find your roots. One of these is going to be one of them. Or you can graph it and see where it passes through the x-axis. The only danger with that is you might find some complex roots. And actually, no, it should still pass through -3. So let's make sure that answer is B. Yep, there it is. One more, all right. And then we will have worked through 42, 52, 132 EOC questions this week, all right? That's a good week's work. So, given that these are factors of the polynomial, what is the third factor? So there's a couple of different ways to work it out. We can multiply that, times that, and see if we get that. Or multiply that, times that, and then that, and see if we get that. And multiply that, times that, and see if we get that, okay? That is one way to do it, because these are factors. There's going to be 3 factors altogether, because the degree is 3. There's going to be 3 factors altogether, so which one of these is our third one? Multiply them all together. But that is a pain, because when you multiply those, you're going to get a trinomial. Multiplying a trinomial times a binomial gives you 6 terms. You got to combine like terms. We got to do that 4 times. Nope, got to be a quicker way, all right? So here's what's the quickest way? What's the quickest way? Here's the quickest way. Here's another way to do it. Let's use synthetic division and divide it by -3, because we know that's a 0, because it tells us that's a factor. 2, 13, 17, -12. Let's see what we have left over. 2, -6, 7, -21, -4, 12. We know we have 0 as a remainder. We knew that. Now, oh, well, no, it's hard to, I'll be honest, I don't remember how to divide by a number that has that A at the beginning. So we'd have to use long division. So we're stuck here with 2x plus 7x minus 4 is our remainder. And then you can factor that. And guess what? We know one of the factors is 2x minus 1. And the other one is here. So let's just see which one is going to give us this. We know the first thing has to be x, and the outers and the inners have to get 7. Oh, the last has to multiply to get -4, so I know it has to be +4. And the outers give us 8, and the inners give us -1. That is 7. There's our third one. B. And there are multiple ways to do this. See if you can come up with another way if you are so inclined. Okay, there's multiple ways to do all of these. That's why I teach you guys strategies. All right, so that concludes our work week of 132 EOC questions, some of which we skipped, some of which we simply didn't do. But hopefully I think this has really brought a lot of these rules back into your head. Hopefully it hasn't been too torturous. I know it's a little monotonous, but that builds stamina, right? That builds stamina. The reason that I'm not a runner is because running to me is extremely, extremely boring. And also when I'm done, I feel like I'm gonna die. So I do not run, and the kids are running in the hallway right now. But I understand about building stamina because I have taken some classes and stuff and built up to working a 5K. So you do have to build mental stamina for this too. And I've had to build mental stamina this year. It wasn't easy for me to just start teaching 4.5 hours a day every day, especially in front of a whole classroom of students, which I'd never done before. So I had to build some stamina up here and some skills that keep my thoughts running even while I'm watching, to see who's on their phone and to see who's eating snacks and to see who is curling whose hair and who, braiding whose hair, and keeping an eye on all that stuff. So I have built some stamina this year for sure. All right, and you guys have too. So I'm very proud of you all. I love working with you. This is going to be, I can't wait to see how you guys do on the EOC. All right? I'll see you guys on Monday. I think it's the 21st. All right, take care.